All right, so let's play first with the interactive mode. All right, so as you type Python 3, this prompt opens. There are 3 greater than signs. For Windows, you might open it directly from the start menu, and it opens in a window, in a text window that has 3 greater than signs. And this is what we call the interactive mode. So Python does have 2 modes. And we'll talk about the other one soon. In this mode, Python, which is very appropriate for learning, right, is an evaluation engine. So you can start with just inputting an expression and you get the result, right? And this is a very nice way to experience especially the types of data that Python can handle. So obviously 3 and 4 are numbers, and we can combine numbers in any known any kind of expression, right? The other type of data that we have is strings, or let's put a name here, Python. All right, and the value of a piece of data is itself generally, right? The value of a number is that number. But strings as values can be involved in expressions. So for instance, Python is nice, right? This is an expression for strings, right? And it results in concatenation. Notice that I'm typing double quotes, whereas Python responds with simple quotes. Both double and simple quotes are acceptable for strings, so I can write Python as well, and it is acceptable. I can mix and match them as I like. Yeah. Why do we have 2 ways? Well, imagine that I want to use double quotes inside a string. Well, I can use double quotes inside a string that is delimited by single quotes, and then I will get Python is nice as single quotes, right? Obviously, if I would use double quotes here, this will be very confusing, right? Because it will assume that this is the empty string, and then there's this sequence of characters that we don't know anything about, and this is another empty string, right? So it doesn't make sense to Python. So if I want to use single quotes inside a string, I can delimit it by double quotes. If I used to use double quotes inside a string, I can delimit it by single quotes. I can do exactly the opposite. Let's say I want to single quote is, yeah, right? And I can do that, whereas if I tried to do double quotes, obviously that wouldn't work. Why? Because, well, this is one string, this is another string, this is something that is now incomprehensible to the compiler, right? And leads to an error. And oh, actually is is not incomprehensible. Sorry.
Logical expression.
Pardon?
It becomes a logical expression. Why is it?
It is, because is as is right. I can say, for instance, the empty string is none, and this is false, right? So we're going to learn about is in soon, but is a Boolean operator, right? So anyway, so the intention is it changes the intention, right? So if I use double quotes instead of simple quotes, this is assumed to be a string, and this is assumed to be this is assumed to be another string, right? Whereas what the intention was that this word here would be just quoted. Yeah, I can accomplish a similar thing by escaping these. So I can put backslash in front, and that is called escaping, and I can accomplish the same thing. But obviously this is not as nice to read as compared to this, yeah? So double versus simple quotes in strings, and we can see that we can have operators on strings. For instance, the plus is concatenation, and we know that plus works for both numbers and strings, so plus is overloaded, right? The operator plus has multiple meanings. For numbers it means addition, for strings it means concatenation. All right? Now, I'm not gonna, typically we would talk about a distinction between integers and real numbers, right? I'm not gonna go there because this is kind of an advanced topic and it doesn't make sense to worry too much about that at this point. But obviously, if I divide 5 by 2, I'm going to get 2.5, which is not an integer anymore, right? Operations on integers are, of course, more precise as compared to operations on real numbers. And at some point, I'm going to show you the distinction between this kind of precision. Whenever we use real numbers, we have about 16 decimal places of precision, whereas it so happens that for integers, precision is infinite. All right, so I can have as many digits as I want. I can operate with integers as large as I want. There's no limit. So one cool thing that we're gonna do is, for instance, compute 1000 factorial, right? Which is a number that has about 1.5 screens of digits, right? So imagine this window filled with digits and then scrolling up a little bit. So that will be the value of 1000 factorial. And we can get that exact value precisely because Python can handle arbitrary precision integers. All right, so let's look a little bit at all the operators that we have. Numeric expressions. Before we do that, let's learn that we can name things. So I can take an arbitrary name. I'm just inventing this name, the name value, and I want to give this name to the value 3, right? And then from this point on, value stands for 3. So I can say value plus 4, I get 7, all right? We call value a variable, right? Let's invent one that doesn't really have a meaning, because you might think that value is special because we're using the word value. I can say a equals 4, and I can say value plus a, and I get 7. Yeah. I can obviously multiply them. All right, and I can use any kind of sophisticated expressions, as sophisticated as we want, right? Divided by 2, so that we can operate with all sorts of numbers and so on. We have a similar situation for strings, right? So strings can be concatenated. We just saw that, right? So I'm going to name two strings, S1, which is ABC, and S2, which is DF. All right, and I can say S1 plus S2, and I will get the concatenation of this. Yeah, I can say 5 times S1. What do you think I want to get?
5 times ABC, 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 ABC.
Yes, right. So the repetition of ABC 5 times. Okay. Other operations that are interesting on strings. For instance, I can I can capitalize. We're going to learn a little bit later about object orientation. One thing that you have to learn relatively early in order to do anything useful with Python is that the operations of a data type can be accessed with dot and the name of the operation, right? So I just used here S1 dot, and I pressed tab twice, and this is the entire set of operations that are available for strings. All right. One interesting one is upper. So I'm going to say s1.upper, and we get the capitalized string. I can turn it into a title, right? Only capitalize the first word. I can do something like s1 plus a space plus s2 dot title. So now this is interesting because it capitalizes every word. And words are any sequences of characters separated by spaces, right? The word separator is space. So whatever comes after a space will be capitalized. Okay. And let's introduce booleans by actually calling this function starts with, right? So I'm going to say s1 dot starts with AB, and we see that the result is true. So this introduces a new type of data. We call them booleans. Have you heard of booleans before? Have you heard of Boolean algebra? Now it is taught in high school, right? So we have two values in Boolean algebra, true and false, right? And they can be combined by a number of operators, right? Conjunction, disjunction, negation, implication, and exclusive OR. Let's introduce those one by one. Conjunction, right? Represented by the word and. I can say true, and notice the capitalization. Capitalization is important. This capital T here is important. So true and false, the value would be false, right? True and true, the value would be true. Obviously, I can say x equals true and y equals false, and then I can say x, and let's introduce or, x or y. Yeah. I can say not x. Yeah, so this would be the negation. And then can I say x exclusive or y? Which is true. Yes, it's true. X is false. What's exclusive OR? It's addition modulo 2, right? So you can think of true as 1 and false as 0, right? And you can just think of the sum modulo 2, right? So 1 plus 1 is 2, but 2 modulo 2 is 0. Yeah? So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0, right? So this is what we call exclusive OR. It's on occasion a very useful operation. All right, so these are we don't have implication directly. All right, we have three types of basic data. Yeah, numbers, strings, booleans. Yeah, everybody. We can aggregate data, right? So having flat data, having simple data is not good enough. We have to put data together in sort of complicated constructs, right? And hierarchically complicated constructs. The easiest way is to create a tuple. Put two values together, right, in a structure. So this would be a tuple, and it is itself a value. All right, and I'm going to say tuple equals 1, 2, 3, 4. I can make it as large as I want, right? This would be a quadruple. There's no limit to the length, literally no limit. I can now, once I have, and we can put inside any kind of data. it's just easier to type integers, but I can say A, and I can say true, and I can say 4.5 and 10 and BC. Yeah, and this is another tuple. If I evaluate T2, I will get exactly the same value back. All right, and I can deconstruct this. I can access individual components one by one, right? So for instance, I can say T2 index 3, and I will get 10. The indices, the ranks of the elements in any kind of sequence, we'll see that there are several kinds of sequences. This is essentially a sequence, right? Always start from 0, right? So this is the 0th element. This is the first, this is the second, this is the third, and this is the 4th. Yeah? So this is how we access the components of a tuple. Why do we want tuples? Well, obviously we have a lot of data, but I want to look at the data as a single unit, a single entity, right? I don't want to see 1,000 numbers. I want to see a table of numbers, right? Or some sort of a collection of numbers, right? They will be structured somehow. Having 1,000 unordered numbers would usually not be very useful if I don't know the structure and the way they were collected, and if I don't organize those numbers in a way that reflect the reality of where those numbers were acquired, then they're useless, right? So whenever we put those numbers into the computer, we are trying to structure them in such a way that they have meaning, right? Or they reflect their meaning reflects the reality from where they were captured. And then we want to treat this data as a whole. We want to decompose it into smaller pieces. We don't always want to go to the smallest piece, right? And we're going to see that when we talk about trees and other kinds of more complex kind of structures, right? So for the time being, we just look at sequences. One important thing about tuples is that they are read-only. They are immutable, all right? So I can't go and say T2, or let's say T1 is assigned 10. This doesn't work. We're going to see later that there are sequences for which we can do this kind of thing. So not for these ones. These are very simple. All right. Other things that we can do with sequences are slices. So I can, from T, I can take the slice from 1 to 3. All right. So I can take all the elements starting from 1 inclusive and up to 3 exclusive. This is what we call a range. And whenever we talk about ranges, everywhere in computer science, the first element is inclusive, the last one is exclusive, right? Because otherwise we can't combine ranges together, right? I want to combine the range of 1 to 3 with the range of 3 to 5, and that should give me the range of 1 to 5. And this only works if the first range is exclusive up to 3, right? So the second range starts from 3, and I'm not counting the same element twice. So ranges are inclusive to the left, exclusive to the right. I should have made, but nevertheless, right. So what can we do with tuples? Well, one thing is we can add them together. So tuples are sequences, pretty much as strings. So they share pretty much all the string operations. So I can add them together, which leads to concatenation. All right, and let's call this T3. And then let's see more interesting slices here. So I'm going to go from 3 to 7. Sorry, T3. All right. So 3 to 7, this would be the tuple. All right. The interesting thing is that we can always count from the right, which is a feature rather unique to Python. So I can go from 3 to minus 1. All right? And minus 1 would be the last element. Yes, and it is exclusive. So this would be the last element. Right? So you see we go up to 10. Right? Because minus 1 is the last element and it's exclusive. Each of the indices in a range are evaluated separately, right? So if you either of them can be negative. So I can go from minus 5 to minus 1, all right? Or I can go from minus 5 to I don't know, 9, yeah, and so on, right? So each of these will be evaluated independently. Whenever you see a negative number, you count from the right? So this would be minus 1, and again, if it's on the left, it would be inclusive. If it's on the right, if it's exclusive. Minus 2, and so on, yeah? If you want to go up to the extremity, you can omit the index, right? So T3 of minus 5 and nothing will just go till the end, right? If I go from nothing to 6, let's say, I would start from the very beginning. And obviously, if I don't include either, it will create a completely new copy of the sequence, right? And it is important that it's a completely new copy, right? We were saying that this is immutable and we can't modify it, right? But when we can modify, when we operate with sequences that we can modify, we may want to not modify the original. We may want to make changes to a copy. And then this will be a very easy way to create a copy. We can also multiply, all right, a tuple, any kind of sequence, exactly as we did with a string. There's a few more things that are interesting to do with a tuple. So let me create a tuple T4, and I'm going to create a tuple of arbitrary numbers. I'm going to try to be as random as possible. Okay. I'm already introducing something interesting here, right? So you see the comma, right? Why was this allowed? It seems like a syntax error, right? So first of all, how do we define a tuple of one element? So that's an interesting question, right? Because you see, if I say 2, this means like the expression, the numeric expression 2 in brackets, right? In mathematics, adding an extra layer of brackets doesn't make a difference. And Python is trying to be mathematically suggestive, so it's just trying to look like mathematics. So the extra layer of brackets looks like this is an arithmetic expression, so it doesn't make a difference. So if I want to create a tuple with one element, I would do it this way, right? So adding a comma with no extra element creates the tuple of one element, right? So this, if I index it by 0, will return the single number. And to make sure that it has a single number, if I try the number 1, you will see that we get an index out of range. So it doesn't have more than one element. One element at index 0, there's no element at index 1, right? So this is exactly one tuple with a tuple with a single element. You might also ask, should there be a distinction between the number itself and a tuple containing that number? And the answer here is a matter of choice, right? So some languages will choose actually to not make a distinction. The number and the tuple containing just that one number, not a difference. But in Python it does make, right? So the creators of Python decided to have a distinction, right? Because the size of 1 is a size as well, right? So we have the size of 0. We have a size of 2. Why shouldn't we have a size of 1, right? It's just a matter of uniformity. So we should have tuples of size 1, which should be distinct from the number that they contain. So obviously, 2 is not equal to 2. And now we learn about equality. Equality as a test is written with the double equal sign. It's just another operator. And why double equal? Because the single equal is the definition of a name, yeah? So we have to distinguish between the two. Cool. Everything clear so far? Any questions? All right. Okay. So let's start learning something a bit more interesting, which are tuple comprehensions. So T4, I introduced T4, sorry. And one thing we can do is sorted T4, and we get all the numbers in sorted order. Notice the square brackets, right? Square brackets are a different kind of sequence called a list, not a tuple. List and tuples are different in only the fact that lists are mutable, all right? I will talk about them soon. I want to explore the field of computation with immutable data first. And introduce the complication of assignment later, of things changing their value later. So let's talk about comprehensions. So let's say I want to generate now the tuple of all powers of all squares between 0 and 100. All right, the tuple of all squares. So I should have 1 for 9, 16, right? So I'm going to generate the numbers of form I star I for I in range 1 to 11. As all the ranges before, 1 is inclusive, 11 is exclusive. All right, so if I evaluate this, I'm going to get exactly that. All right, let's go a little bit further. I want to generate all the squares that are also even. All right, so I'm going to add a clause if I %2 is 0. I %2 is the remainder of the division, right? The modulo operation. So I'm dividing I by 2 and checking the remainder of the division. And that remainder, I want it to be 0. And I'm going to filter out all the numbers that do not satisfy this and keep only those that do satisfy. So if I evaluate this, I will get all these square numbers that are also even. Yes?
Why did 2 square, like 3 square be 1? Like, because you have them twice in the tuple. That's the T4.
I'm not sure I understand, right? So this is multiplication.
I saw the wrong tuple, sorry.
This is multiplication, and what was the question?
Oh, no, I saw the wrong tuple.
Oh, I see, okay. We can create tuples of tuples, and this is actually much more common than you might think. right? So let's say I want to generate all the pairs of numbers between 0 and 5. Let's just do that, right? So I'm going to say tuple, and I'm going to have inside another tuple ij for I in range 1, 6 for j in range 1, 6. Okay, so this is all the pairs, 25 pairs of all the numbers, right? We're going to have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, then 2, 1, 2, 2. Let's say that we don't want all the pairs. We want only those where the first number is smaller than the second number. So we can easily add if I less than j. Right? So we get only those pairs where the first number is smaller than the second numbers. Let's say, on the other hand, that instead of all the pairs where I is less than j, I want all the pairs that add up to 10. Right? So then I'm going to say if I plus j equal 10. Oh yes, 10 because it's up to 5, so only 5 will. Let's make this smaller, up to 6. Yeah. So I'm going to get all the pairs that together, they added together, they produce the number 6. Okay. So, any questions so far? Yeah.
Why is there a comma after the 5 5s? Like the first tuple that you.
Because it's a tuple containing a single tuple, right?
Oh, okay.
The outer tuple only has one element,
Okay.
right? And the only way to signal that is,
Comma.
yeah.
Going back to the SI tap thing, it didn't work for. So is there a different function for doing those?
Going back to,
You know how you did like SI dot tap tap, S1 dot tap tap tap.
oh, I see. Are you using a Windows machine?
Yeah.
Probably that's the one. That's why.
It doesn't work for us.
The reason why, what you can do in that case is, what was the S1, right? So what you can do in that case is say dear S1, right? So you get a somewhat less nice, less nice depiction of all the numbers, right? You can ignore the ones that have double underscores, right? And then this is the set of operations that you have on strings. And this is an alternative way of finding that information. Okay? All right. One interesting thing talking about strings that is nice to it's nice that you actually reminded me of this. So there's an operation here called join. All right. So let's say we have a bunch in a tuple. Let's say we have I'm going to call it T. We have a bunch of words. What is the quick brown fox jumps over the lazy dog. So this is a very useful phrase because it contains every single letter of the alphabet. So if you want to see how a font works, right, by writing this down, you can make sure that you have written every single letter. Or if you want to type, if you want to check a keyboard, how is a keyboard good for you, right? You type this phrase, you have touched every letter on the keyboard. So now we would like to turn this into a phrase. Obviously, words should be separated by spaces, right? So the way to do that is we take the space, which is the separator, and say join T, all right? And we get it put together into a phrase. Obviously, this space is the character that fills the space between the words, right? So if you go here and say slash, you're going to have slashes, right? So this is also very useful when you have when you have a path and you don't know where you are. Are you on Mac OS or are you on Windows, right? So you keep your path in a sequence, right? These are folders. And then you turn the path in either slashes, separated with slashes, or with backslashes, depending on whether it's Windows or, yeah. So the backslash is actually the escape character and has to be escaped itself always. Yeah. All right, one important thing that you have to learn the distinction of that. Notice that as we are in the interactive mode, we're going to leave the interactive mode very soon. As we are in the interactive mode, every expression is evaluated and then a result is printed, right? There is a distinction between printing the result of ABC and performing print ABC. Can someone explain why?
Because when you're defining a function, you have to, if you want something to print ABC, you can't just write ABC at the end of a function and it won't print ABC by its own. You have to instruct the computer to print that particular thing. But since it's because it's at the interactive mode, it's at the start of the interactive mode, you type ABC and it returns ABC.
Yeah, well, so we're dealing with two concepts here. One is the value of an expression, and the other one is the side effect of an expression. For instance, if I say z equals print ABC, okay, is this going to be correct? Am I going to get an error for this? No, right? So the print ABC still happens. What's the value of z? All right, so you see nothing is printed. Interesting, right? But if I say z is none, I get true. None is a value, right? So mathematics has this nice way of creating uniform concepts, right? So like zero, right? So 1, 2, 3 are values, represent quantities, right? So you invent the notion of zero, appearing that nothing is also a quantity, and then you can treat everything on the same level, right? It's you can't, so you don't say I give you nothing, you say I give you zero. It appears that as I'm still giving you something, right? So that zero represents the nothingness. So this value represents the concept of no value, right? Print doesn't have a value, therefore it has the value none. And then the value none doesn't have a string representation. So if I say none, nothing gets printed. None has no value, right? It seems that everything else has a value. I do ABC, right? The interactive environment returns to me ABC. But whenever I say none, it returns to me nothing because there's nothing there, yeah? But the important thing to understand here is that every expression has two potential things attached to it. One is the value, and the other one is the side effect. So this expression has no value, has a value of none, so has a value which is of none, but has the side effect of printing whatever comes as an argument to the screen. Now, when we go out of the interactive environment, the values, even though they exist, they never get printed, right? So the effect of putting ABC in the program, I can put it, it's legal to have it there, I will see nothing on the screen, yeah? But if I put print ABC, the side effect of this will be visible both in the interactive environment and in the batch environment. Yeah. So we'll soon go to execute Python files, right? And whenever we execute Python files, all the values that we have been seeing will no longer be on the screen. What will be on the screen is the result or the side effect of print. Print takes this as an argument, as a side effect, it puts it on the screen. So we will have to use print all the time, all right? So let's do that. I would like to at least show you how to execute Python files, and then we're gonna go next time into defining procedures. What have I done here? I didn't intend to do this, but I think I can just turn them off. Yes, okay. So Control D to exit. All right, so what I recommend that you do for this module is create a special folder. So I'm going to go to mine already. And then I'm going to move my current Python to Python 3, and I'm going to create a new folder, Python. And inside here, I will create a separate folder for every new class, right? So this class is week 1 on Thursday. Yes, and I am going to put an underscore there so that I make sure that week 1 Thursday appears before week 1 Friday. Yeah, I'm going to have week 1 underscore Thursday, T, and week 1 without underscore Friday, so that they appear in the right order. And inside here, I will put my Python file for today, which is going to be a very simple one, right? Now, how do we create a Python file? And I'm going to give you the very basic ways of doing that. Yeah, and I know that some of you have probably have a problem with those of you who are in Windows. You exited the Python environment and you don't have a place where you can look at the folders. And I'm going to teach you very soon how to overcome that, right? So the important thing is go and create a folder that is specific for this class. Yes? To create a file, I recommend that you use what we call an IDE, an integrated development environment. I use Visual Studio Code. And I still have a lot of well, I think we can delete this. All right, so this can be easily downloaded. You just look for Visual Studio Code, right? You will get a link to download. It's available for both Mac and Windows. You can use many other tools, but again, if you do, you're on your own. What we do here is we open a folder. So add a folder to Workspace, and I'm going to add the Python one, and I'm not sure whether I can remove this one. Remove. All right, and I'm going to create a new Python file. So I'm going to say batch mode or hello world. Let's just .py, right? So it's going to be a very simple file. We're just going to say print hello world, and this is the entire code. The other thing that I would like you to experience is just above, I'm going to put a 5 plus 3, right? And I want you to experience the fact that, first of all, this is not an error. We used to type 5 plus 3 in the interactive environment, and it was fine. It's fine here too. But you're not going to see 8 anywhere, right? We're going to run this file. You're not going to see the number 8. We will nevertheless see hello world on the screen, right? So only what we print is visible. And I'm going to say print, and also 5 plus 3, and or let's not make it the same, 5 plus 6, and we're going to see 11 on the screen. Okay, so now I'm saving this file, all right, and I'm switching to this place where I had the interactive environment. If I look at the directory, you can see the file that I saved. I can actually even see the contents of the file here, and you can see that the contents is exactly what I have typed. Yeah, and now I can say Python 3 hello world, and then this is the result of the file. This will be, so you see the effect of the print, right? The print happened here. The print also happened here. This line must have been executed. It's in the file, must have been executed, must have been interpreted by the interpreter, but there's no evidence of that on the screen. Why? Because we didn't capture that result in a print. So it's not wrong to have it, but it's useless. Okay. Now, how do you run it if you're on a Windows machine? Yeah, so that's a very important question right now. So I would like you to open your, so make sure that you have created your files. I'm going to come to each of you and actually teach you how to run this file. So make sure that you have created this file. All right. This will be our preferred way of running files from now on, because it's the most basic way of interacting with a computer. Yeah, so can you go to the folder, to the location of this?
What you said this is it.
Okay, so is this the executable? Yeah, so follow the link.
Is that open?
No, follow the link.
You probably should work with someone else, yeah.
No, so one of them in Windows is follow the link. Open the link location. Yes. Okay. So I'm going to take this. No, I'm going to take. Sorry, this is tricky. So Control C, and then I'm going to open CMD. Oh, you open regedit. So you must be not completely unaware of these things, right? So now Control V here. I'm going to. So this is the folder, right? Where's your here, right? Python. No. What's the name there? Python. Oh, I see. Because which one is home? So, where's your file? The file that you just created?
Files, the documents.
Okay, let's come out of here. Go into documents. No, it's good.
I
I'm
just
gonna take this thing, Control C, go here, CT, Control B, and then I'm gonna go back to this. So this is a line I have to remember, yeah?
Okay.
And then hello world.py, and you get this, yeah?
Okay.
So the equivalent of what I did in Mac, and this line, put it somewhere, yeah?
Okay.
Remember it. Okay, next window machine. That's not the one. That's not the one. Okay, it's good that people are switching to Macs.
Yeah, let's go.
Unix, you should be an expert, right? You don't have to tell me anything. Mac, yeah. All right. So you save this. All right. So we're going to take your. Oh, why is it untitled?
This is
Save it as one. Control as. No, so save it as.
you saved on the read on Tuesday.
So I'm gonna.
You ever save it?
No, I had the charging problem.
Save it. You save
Okay,
this.
sorry. So we're gonna do the folder. Quotes. Control B. Oh, it is in documents. Oh, it's in documents. All right. So now, if I type Python. Wonderful. This is a good installation. So I can search Python. Yeah. So this is the Mac. Mac. Did you create a file? Did you download? No. Okay. You need to know how to install. So. So we're gonna open a window. how to install.
Can you mention that install how to install the data file?
All right. So the important thing is you have to know how to run Python in here. Yeah. So the problem is, for some people, if they install it correctly, yeah. So you can go here. You can search Python, right? Oh, have you installed Python? So you can follow the links. All these that you're seeing there are links. This is another link. How do you know it's a link? There's a little arrow here, right? That's the. So you can say open in, and then this one is not a link, right? So I can take. Sorry, this is where it resides. So I'm going to take it out. See. Space right. So now you saw me typing Python on the command line, right? And when I open Mac, do this, you get the same thing, right? So I had the same window. For me, it works by just typing Python. For you, you'll have to save all this thing, right? So put it somewhere in a document somewhere, and then whenever you come to class, copy paste from there. Yeah. You can exit from there, Control C. And now, if you have the file, all you can do is take this thing, space, right in front of it, it will run. Yeah, let's try to do that. Yes, you did well. All right, so okay, this is good. So we're going to open the terminal, right? CMD. More complicated. I want to go to the. Yeah, we have to save this one. Control S. And let's call it hello world. Oh, just type Python 3. And then you can exit the console. So I don't know. You wanna go? One level up. One level up. Yeah. Zone, no spaces. No spaces. Generally, spaces are reserved for different separate entities, not words. All right, so I'm going to take the spot. I'm going to put it there, right? So I'm going to take P. Yeah, so now I try to those here. I will see this this is it. So next time we're going to start writing Python code in files and run them and see how much more stuff we can do because of that.